How's it going? My name is Nicholas Scarrett, and this is my 2211 Physics Lab 1. So, what is the purpose of this lab? Well, the purpose of this lab is to understand Newton's first and second law of motion. We will compare a computational model glow script and an observational model tracker of an expo marker traveling in one direction. We then will observe that there is a difference of result between the two models and brainstorm as to why. So the two fundamental principles of this lab are Newton's first and second law. Newton's first law reads an object at rest remains at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. And Newton's second law reads the net external force equals the change in momentum of a system divided by the time. And so we know that Newton's second law states that F net is the derivative of momentum over the derivative of time. And rearranging this equation, we can actually see that we can get a velocity final with this, get over momentum initial plus F net over mass times delta t. And so in a real system, there's going to be net forces all the time. But we'll see that there's a discrepancy between our computation and observational model, between the numbers, because our computational model does not account for net forces. So what is the system and what are the surroundings? So the system in this lab is going to be our expo marker. This is the thing that we're going to be studying. And then pretty much everything else that's interacting with the marker is the surroundings. So the system plus the surrounding is literally just everything. So, this could also, be like gravity, air, friction are all things that affect our system. So, taking the video, I just threw a marker among a meter stick, calibrated that meter stick, and then pinpoint the center mass for each frame of the video. And then I got this data, put it into a graph, and one discrepancy here, however, is that between 0 and 0.1, this is inaccurate. I was not able to get that one frame. So the data used for the glow script, since this is a constant force, we're using the V average for constant forces and finding that our initial position, our final position, and our initial and final time, we find delta t is 600 milliseconds, and then V average is 78 centimeters per second, with the frame rate being 1/30. And here's the actual code for GlowScript. We did not adjust the mass for the ball, but the initial position, we put a negative 0.232, and of course we plug in that 78 centimeters for velocity, meters per second. We set the time less than 0.6, which is the entire length of the video. We do not have a net force in this. We are not accounting for any sort of net force affecting the system in this case. Then we do ball plus Fnet, which is just going to zero out, so this part is not very important. Position is pretty important. This is just adding the velocity to the position inside this while loop. Here is the data graphed out for the glow script. So we can see this is a very straight line. There is no discrepancies, no net force affecting the velocity. It is a constant velocity. So here's the two side by side, and they look pretty close, I would say. But if you look a bit closer, we can see our computational model and our observational model are not quite aligned, and we'll see that there is a farther distance projected than the observational model over here. And this can be explained by Newton's second law. There is a net force in our observational model. So some errors, one I went over a little bit earlier, but placing the center mass was, very close, but maybe not exact. Rounding errors could throw off numbers, of course, and, well, the predicted went further than the actual, and this shows us that there was some force at work. So lab still works. And for the what if section, if we were to flip the axis, all that would mean is that I would have a negative slope and the direction will be changed, meaning it'll go to left rather than right. So for the what does it mean section, to answer this very briefly, no, it is not possible to figure out how many pushes and pulls are affecting this marker at this given time. There's just too many things in the universe to account for, and they all have some effect on the marker. Thanks for watching. Oh, and don't forget to like, comment, share, tweet.